Okay. The next proof style is a proof by contrapositive, or sometimes it's called a proof by contraposition. But what we're going to do is we're going to prove the contrapositive of the statement. And so a good example here, well, let's talk about this in general. So if I want to prove the statement P implies Q, what we'll do is we'll assume Q is false and deduce that P is false. And so what's going on here is that if you remember, the contrapositive of P implies Q is the statement not Q implies not P. So a proof by contraposition of P implies Q is really a direct proof of the contrapositive, not Q implies not P. So we're going to assume that Q is false and deduce that P is false. A good example here would be that let's prove that if x is even, prove that if x squared is even, then x is even. And so I want you to notice what's going to happen. And so let's start off with a proof that's not going to work. So assume x squared is even. So assume x squared is even. Then there exists an integer k, so that we can write x squared is equal to 2k. And thus x is equal to the square root of 2k, or plus or minus the square root of 2k. And this is bad because now it's not clear that x is even an integer anymore. It depends on what k is. Okay, and so it's not even clear what x is. Is x an integer? Is it like square root of 5? I mean, is it square root of 10? Is it, what is it? So it's not clear what's going to happen if we let x squared just equal to 2k and go from there. So what we have to do, so that's why this direct proof isn't going to work. So what we have to do is we're going to prove the contrapositive. And let's think about what is the contrapositive. Here our statement, and again, I just want to kind of zoom in on the details here. But here our statement is that if x squared is even, that implies that x is even. Okay. And so what's the contrapositive? The contrapositive would be that if x is not even, then x squared is not even. In other words, if x is odd, then x squared is odd. That is a statement that we can work with. Okay, so we will prove the contrapositive. At least when we start off with this in this chapter, if we're going to do a proof by contrapositive or a proof that's anything other than a direct proof, I like to write out what it is. So we will prove the contrapositive. This I just think of as kind of leaving a breadcrumb trail to our readers, making it as easy as possible for them to follow along. So we will prove the contrapositive, and I'm just going to kind of capitulate what that is. We'll prove the contrapositive if x is odd, then x squared is odd. Okay, and so that's a much more straightforward thing to prove. And of course, that's equivalent to what we said before, because any implication is equivalent to its contrapositive. So let's do this. Let's prove that if x is odd, then x squared is odd. Well, assume x is odd. So assume x is odd. What does that mean? Well, that means that there exists an integer k, so that x is equal to 2k plus 1. And then all we have to do is compute x squared. So therefore x squared, which is 2k plus 1, is going to be 4k squared plus 4k plus 1. And notice that that's a multiple of 2 plus 1. So x squared is odd, and we're done. Okay, nothing fishy about thinking about whether x is an integer or not an integer, or oops. I'll edit that out. Okay, so nothing, yeah.